Hello friend, welcome to Dr. Subhash Technical Campus, Junagadh. Today's tutorial topic is insulated gate bipolar junction transistor. Simply it's called IGBT. Now this topic will cover in power electronic subject. Now let's take a look. First of all, let me start with classification of power semiconductor devices. Now, power semiconductor devices is nothing but it handle very high power, means high voltage and high current application. The two terminal, first of all we divide in two terminal device, and this is the three terminal device. According to the terminal of the device, the two terminal device is pin diode, PIN diode, then Schottky diode. These two type of diode or power diode. Then three terminal device is nothing but power MOSFET, JFET, IGBT, then BJT, then thyristor. These all are power electronic devices, and minority as well as majority charge carrier device is there. So according to the N type and P type semiconductor material, the majority and minority charge carrier devices is, we can say that this is the majority charge carrier devices and this all are the minority charge carrier devices. So this one about the classification of the power semiconductor devices. Now IGBT. In this figure we see the practical or physical view of IGBT. This is the high power application in industries. This type of in place of contactor we can use the IGBT for the high power application. This is the symbol of the IGBT. Here the three terminal device, collector, emitter and gate. In place of base, here we have to write gate, because this is the higher version of or mixing of MOSFET as well as BJT. So insulated gate bipolar junction transistor is similar is a transistor BJT, but some extra feature is there, we will discuss in next slide. The insulated gate bipolar transistor, here you have to remember this symbol. Then next, the first evolution of IGBT, let's start with one by one. The first step, bipolar power transistor. This is the symbol of transistor. Here mainly the construction design of higher version of transistor means if we add some extra features in BJT, then it handle the more power. Means bipolar power transistor uses vertical structure for the maximizing cross sectional area rather than using the planar structure. Here we use vertical structure for the maximizing the cross section area. Here this is the structure of the first bipolar power transistor, and this is the symbol of the power transistor. Here in power transistor, here this line you have to draw the border, so we can easily identify this is the power transistor. In transistor there is three terminal, collector, base and emitter. Simply simple PN junction, NPN or PNP. Here this transistor is a NPN transistor. Now next is power MOSFET. Metal oxide semiconductor field effect transistor is power MOSFET, means it handle the more power. The power MOSFET uses a vertical channel structure versus the lateral channel devices used in IC technology. If IC means integrated circuit design technology, it used the vertical channel structure. So we can directly say that this is the source, drain and gate. This three terminal device, source, drain and source, and here there is a channel between drain and source. So directly current will flow from the drain to source. Now this is the symbol. Here this arrow is outside, so it is N channel JFET. If arrow is inside, then it is P channel JFET. Here FET is a one types of transistor, but higher version of FET is known as MOSFET. So drain to source, then according to the gate pulse or gate voltage, the current increase or decrease. So this is the structure of MOSFET. Now lateral MOSFET structure is like this. In this figure we can see the different terminal of the MOSFET, source, gate and drain. Here the channel, this permanently between drain to source channel is available, and channel width is increase or decrease according to the applied gate voltage. So this is the lateral MOSFET structure, And in the evolution of IGBT, the third part, the BJT discrete plus MOSFET discrete, power MOSFET discrete, then whenever we connect BJT as well as N MOSFET, NPN transistor and N MOSFET using Darlington configuration. This configuration is known as Darlington pair configuration, because the base of this transistor will connected to the source of this N MOSFET. So this fundamental connection become Darlington connection of the IGBT. So this is the main parts of the evolution of IGBT part 3. Then evolution of IGBT part 4, BJT physics plus BJT MOSFET physics is equal to IGBT, means more powerful and innovative approach to the combined physics of BJT with physics of MOSFET within the same semiconductor region. This approach is also termed fundamental integration of MOS and bipolar physics. Means here mixing of BJT and MOSFET, so we can design using this concept, the insulated gate bipolar junction transistor is emerged. So if we want to design IGBT, then BJT, the concept of BJT as well as concept of power MOSFET, you have to combine each other. The superior on-state characteristic is occurs, then reasonable switching speed and excellent safe operation area, means these are the advantage of the IGBT. So if we want to use the IGBT for the high power application, then it is more suitable than the power MOSFET. Then evolution of IGBT part 4, BJT physics plus power MOSFET physics, means here IGBT fabrication using vertical channel similar to the both of power BJT and power MOSFET, means if we design this structure with mixing of BJT and MOSFET, then it works or look like this. So if we want to design IGBT, then you have to first of all remember the characteristic of BJT, then characteristic of power MOSFET. So you can easily design the IGBT. Okay friend, here the IGBT is nothing but higher version of MOSFET, and here we can see that if we want to increase the input impedance, then the higher input impedance will be achieved using the IGBT, because impedance is high, then more power handling capacity and more linear devices become. So for the switching purpose, in today's industrial switching purpose, IGBT is more suitable in place of contactor. So it is a noise level is very small, operating voltage is very small, and it handle the high power. So we can say that the today's power electronics controlling device, IGBT is more important for the switching as well as the controlling device. This one is about the advantage. If we talk about the advantage, superior on state characteristic, means here the switching speed of IGBT is very high, means high frequency switching or AC drive or DC drive, whenever we want to change the frequency as well as the on-off state, then IGBT is more suitable, means the superior on state characteristic as well as reasonable switching speed, means high frequency switching on time and off time. Whenever we want to fast switching, at that time majority charge carrier combination and minority charge carrier storage will very small, then easily we can on and off the high power. So these are the advantage. Also the excellent state safe operating area, here safety purpose, means whenever we use on-off purpose, whenever we use a contactor, then it very noisy and the safety is not good as a IGBT. So you have to remember this excellent advantage for the application purpose, as well as the IGBT. Nowadays the IGBT is become most common for the power application or power electronic devices, and the higher version is also available. According to our requirement, we can set the different level or different characteristics, so easily we can understand or easily we can maintain the power level. So, first of all you have to remember 3 terminal is same as the in 3 terminal the 2 terminal from the BJT collector and emitter, and 1 terminal is from MOSFET gate. Gate is taken from the MOSFET and collector and emitter will taken from the transistor. So, we can say that if it IGBT is nothing but is a mixing of transistor and power MOSFET. Here transistor is nothing but power transistor. Whenever we add some power transistor and power MOSFET, then the characteristic of transistor as well as characteristic of MOSFET will added in this MOSFET. So, we can say that IGBT is a more suitable and more important device for the power electronic. So, okay friend, this one is about the IGBT. Now, in next video, next tutorial, we will see the different component and different application of the component. Okay. Now, this is the basic construction of evolution of BJT as well as MOSFET. So, we can say that this IGBT fabrication using vertical channel similar to the both BJT and MOSFET. This is the vertical construction, and using this vertical construction we can design the structure of IGBT. So, we can easily modify the our voltage and current. Okay friend, this one is about IGBT. If you have any query or doubt, then you can write on this email ID chetanb@drsubhashtech.edu.in. Okay, thank you.